All right, everybody. Today we're going to talk about a little bit of object-oriented programming. I know that it seems like we've taken this for granted for a while now. We've been working with Python. Um, okay. Yeah, keep working on. I'm going to spiel for a little bit about objects and classes and attributes and methods, and then we'll get to the code along in like 5 minutes. So we've been working with Python for a while, and you may have noticed that it works a little bit differently from some of the other programming languages that we have seen in our world. So the dependence upon objects being instantiated from classes makes Python agile, widely applicable, and fairly easy to use versus procedural languages. Um, and my baby, which is R, only has specific methodological functions. All these chats are coming in. Yeah. All right, so when we're talking about object-oriented programming, we would be remiss if we didn't begin with classes before we talk about objects. So a class is your blueprint. It is the concept of a subject, and then an object is the manifestation of this. We use cars here, so we know that a car vaguely probably has four wheels. It probably has a front windshield and a back windshield that is intended to carry a couple people from one location to another. There have been a couple of cars which had different numbers of wheels. The Reliant Robin is the one that comes to mind. It wasn't very reliable, but generally speaking, you know that all cars will have some aspects in common, which are attributes, but they're not all the same. So when we instantiate an object from a class, we are bringing with it those attributes. So by definition, an Audi should have the basic same functionality as a car, although there might be some differences such as horsepower, price, the population being marketed to. And you might say, well, what's the benefit of having a class and then having to instantiate an object? Why do we have to have this multiple step situation? Because let's imagine you're in HR, and every time somebody files a complaint, you have to rewrite that code from scratch, talk about the nature of the complaint and the date and the time and how many people were involved. It's a lot easier if you have a template to draw from and you just input a couple of the details. It can save you a lot of time in the long run. It's also very profitable to understand how OOPs work. C++ is or C# and C++ and C are procedural, but Java, JavaScript, and Python are OOP. And if you know them, you will be very hireable. My baby is all the way down here. Very few people want us. All right, so when we talk about the method to organize your code with an analogy, so attributes are features of the object, and methods are operations that object is capable of doing. So for example, features or attributes of this car could include number of windows, material which is made out of metal, but the methods might be like drive, stop, run people over, etc. And those sorts of things are inherited from the class. So let's start by making a class. The first thing we're going to do is build an empty class called robot. We're not going to put anything in there yet. We're just making the vessel for our ideas. So we'll start with class. That's easy enough. It's robot. It's empty. And then we don't want to do anything yet. So I'm going to say pass. Just leave it be. I'm seeing the chat window blowing up. Okay. Yeah, we don't want to lose our work from SQL. All right, so now we have our empty class. Now we need to instantiate it. We're going to have two objects, Wally and Rob. Rob was not in the movie, in case you've forgotten. We're maybe making, there's already been a sequel, right? A sequel's in, okay. well, we're going to make the SQL and it will have Rob in it. So first thing, we have to name our object, and Wally is a robot. So we're going to go ahead and throw that in there. And then we got to give him some attributes. So with Wally, we're going to give him a name. I mean, spoilers, we already gave him the name, but we're going to make it formal, and we're going to stick it with the attribute name so that when we call name later, it will be explicit. So there it is, Wally.name. And we're going to give him a height. Seems arbitrary, but why not? Maybe we can also give him hopes, dreams, and ambitions down the line. So Wally is 100 centimeters. Actually, let's move that outside. And it's a number, it's not a string. All right, so his height is equal to 100. We don't want to do that. All right, so if we're going to make Rob, we're going to do the same thing, but we're just going to put in Rob's individual specifications. All right, so Rob is also a robot. Rob's name is, in fact, Rob. And Rob is 200 centimeters tall. All right, so let's find out. What if we call upon the attributes of Wally and Rob? All right, so first we're going to call out Wally, and then we're going to call out Rob. As you can tell, I don't really like live coding, but I'm rolling with it. Makes me very nervous to be watched while typing. All right, well, there we go. Names with proper casing, and we have the height. And we could do this for any number of attributes. 500 attributes. If we call them, they will come. All right, so what if, let's go back to that HR example, and let's imagine we live in a world where most HR complaints are asking for higher salary or feeling like you've been kind of shafted out of what you think you deserve. So we would say like the default complaint for HR is beef with money or dissatisfaction with compensation. So you can make a default, and then if you don't specify, that is going to be the attribute that's passed down to every object, and you don't have to specify it. So let's bring this back to our robots. So its default is going to be Bob. It's going to default to 50 centimeters, and it's going to be a little love bug. So its purpose will be to love humans. All right, so we're going to start over. Class robot. And we're going to name it Bob. And his height will be 50 centimeters. And his purpose, to love humans. Isn't that nice? So now, I mean, before when we instantiated, we gave them these specific things. But now, name, height, and purpose are going to be part of the package deal every time we instantiate our new object. And we don't, if we want to change it, we can specify. So now we want to create a different kind of robot. And it's Bender. Bender occasionally wants to kill humans. He usually just wants to drink beer and get into mischief. All right, so now we can't just have it be robot again because it'll erase our stuff. So we'll have evil robot. There's the second one, robot. All right. And because he's coming from the class of robot, actually, we're instantiating. So we're going to have to specify that he's not Bob, that he's not 50 centimeters, and that his purpose is not to love humans. So all right, so he's not Bob. have to have all caps. And 3 exclamation points. How tall do you think Evil Robot's going to be, you guys? I can't hear you.
A few times as tall? Are we just like within any random height range?
Well, if I leave the code exactly as it is now, how tall is he going to be?
Oh, 50.
Yeah, because he defaults to that 50 centimeters.
Yeah.
Good job.
I have a question about the default. Can you use the init method to set it, or do you want to just do this?
We definitely can, and in fact, it's coming in like 15, 20 minutes.
Okay.
Yeah. Init is much more efficient, but we're showing, baby steps first. So now we have Bender. We got Bob, we got Bender. So how would we ask him what his purpose is? We're going to use a little print statement and throw that in there. We'll just plop it on in there. Oh. All right. What have I done? Oh, okay. Dot name. Okay. Easy enough. So back to our HR situation. Can you imagine if you had to send an email to everybody who has filed an HR complaint and you're working in somewhere as large as Google? What if you automate your email sending and you use this kind of template with classes and objects, and you could say, we received your complaint about purpose of complaint from this department. Anyway, you can see how this is very useful for scaling. All right, so we can use that same robot class and instantiate Wally and Rob again. All right, so Wally's robot, home row keys. Do we want height or do we want purpose, you guys? Let's do height because then I don't have to think of something on the fly. All right, so we got Wally. He's 100 centimeters, and that's his name. We can use that robot class. And then Rob equals robot. All right, too easy. All right, so now we're going to compare them. Pay attention to this because in the second activity, you will be fighting some creatures that you design, and you don't know yet which attributes you're going to be comparing. So we're going to see which of our bots is the taller. So tall bot will be Wally if Wally's height is greater than Rob's height. And if Wally's height is not greater than Rob's height, it's going to be Rob. Too easy. So this is, imagine you have like WWF and they're announcing these guys as they're coming into the ring. close parentheses. Let's see if it works. All right, Rob is taller. But why is it saying that he's 200 centimeters tall? If Rob is only 150.
His height earlier?
Can you speak up a little bit?
Because you said his height earlier in the notebook.
So it's calling back to that height, but not this one.
I think you just need to run that cell.
Oh, that makes a whole lot of sense. Okay, there we go. That'll do it. This is why I don't like live coding. All right. Oh man, robot racism. You must be the same, right? Aren't you guys all related? So are they both instances of the robot class? In fact, they are. So are they equivalent? We're going to use that double equal sign. And in fact, they're not. Their heights are different. Their names are different. And if they were exactly the same, you might be wondering why to even have multiple objects with the same attributes. All right, generic default robots. These are just average Joe Schmoes. I don't even know if we're going to name them. In fact, I don't think we are. All right, robot's empty. We're not even going to give them any special attributes, so they are going to instantiate right from the blueprint. Are they going to be the same? What do you guys think? Why is that?
Still two different instances of an object.
Yeah, they are. And I mean, oddly enough, just like naming it different things without even changing the attributes is enough for it to count as different.
Mm-hmm.
So what we're going to do to trick it is we're literally going to just make a copy of generic robot 1. So let's see. All right. So, I mean, by definition, it's equal. If this one says that they are not equivalent, I'm going to be shocked. There we go. Fantastic. And they're going to have the same name.
It's
You are right. Here we go. I tried to make them too generic and I didn't even give them the name. There we go. So it copied and included those names. All right, let's see if we were able to change it after the fact. Uh-oh. Why is that? Because they're the same, they're linked. So when one changes, the other one takes it on as well. Okay, cool. I know this is terribly exciting. A lot of you have previous experience with OOP and you're like, all right, get to the beef. So I think the first bit of beef is methods. So now our robots are going to be able to do things. So let's build it. So when we are first creating our class, we don't want to give them a name. We want to leave that able to be filled in. Most of our robots are going to be metal, so we'll have that as our default. And we're going to assume that they're electric and it's not a steampunk world. And we're going to give them number of arms. 2 arms. Probably 2 legs, but we're not going to specify. All right. Oh, we're going to define a function, or a method in this case. Now we're going to have electric shock. And when we call upon that function, we're going to print zap. Oh my goodness. I have to capitalize the N and none. There we go. All better. All right. So we have our robot, any old robot. Lo and behold, it works. We can call the function from inside of our class. Okay, so what's going to happen if we make a brand new robot? Is it going to be able to call upon that function? What do you guys think?
No.
Okay. Are you looking ahead to the next line and suspecting that maybe?
Yeah. I just remember like if you call in a name, it has to be something within the function itself.
Fair enough. Okay. Yeah. Did y'all hear what he said? Any questions? It's not going to know that it has this function unless we tell it. So just to show that this is true, we're going to say robo, not robot. So there's too much roboting going on. So robo is a robot. Hypothetically, he's been instantiated. But can he use electric shock? No, he cannot. So here's where we get to self. Self is like in the classic Superman story. He has all of these abilities inside of himself, but he doesn't know what he is. It's almost like the realization that he is an extraterrestrial unlocks all of these abilities. And he knows that they're no longer strange. He's supposed to be doing it. Or an amnesia patient realizing that, oh, I'm human. I probably need to go out and get a job because humans get jobs. And realizing that they are an instantiation. So they have their little existential crisis and realize they were brought down from a caste. And then they proceed to have their functions. So let's do it again. Actually, I typed slowly, so let's grab them. All right, so same number of arms, and electric shock is the same. But when we create robo, we're going to have self included. Okay. So we're going to put self inside. Now let's see what happens. There it is. So self made all the difference. And we can put self into all kinds of different functions inside of there. All right, now we're going to do the same thing, except for we will get them to identify themselves. So if the cop stops them on the street, they're ready. So now we're going to define a new function for the robot class, and this one's going to be called speak. We're going to go ahead and put self inside, and when we call upon this function, it will say, hello, my name is name. Too easy. All right, so now we're going to make George. We're going to ask it to speak, and hypothetically, because self is included, he should actually tell you what his name is. All right, and let's see what he says. If I can type it. Well, it seems like it's not able to have this sort of internal awareness that can call upon its own name. So we're going to go ahead and change it up, and it's going to grab self.name instead. So it's going to be all of this, except for we're going to put self.name. There we go. Now he knows that his name is George. All right. Are you guys feeling okay with the possibility of building your own robot and getting them to do things? Okay. Well, what we're going to do is we will put you into breakout rooms in pairs, and you guys will take 5 minutes to make your own robot. We want it to have 5 attributes and 3 class functions. And these can be really strange functions. They can pick up dog poop, they can go for a stroll, they can yodel. And they can be tall and wide and anything that you want. 2 versions, so we're talking like Bob and George, or you can make robots after the 2 of you. So yeah, and then when we come back, one group will share the results and the second group will record for the folks at home. All right, Matt, would you kindly stop recording and then we'll put them in.
So I'll share my screen. So we didn't get to finish our part. We were just doing the attributes and the functions. So we named our class of robot with no name. The material is rubber, false electric, type 15, number of head space. And then we wanted to, the one that we did was to see if we could stretch him. So that was going to be his function, right? And so in order to check if it worked, we would have to do, guys, Susan, well, the name of our robot was Susan, or was going to be Susan. And now we have to check it and see if our functions worked, right?
Yeah.
So,
Yeah, so you want to do Susan
equals robot. Yeah.
Yeah.
Susan equals robot. And then Susan.name equals Susan.
Okay.
And we're gonna leave the height the same
Okay,
for
right.
this one. And then the other robot, Jeff equals robot.
Jeff is a good robot name.
Jeff.name equals Jeff. Jeff.height
Mm,
equals 50.
okay.
Uh-uh.
So that should make our robots.
And then to check it, we would do, I'm sorry, I always go back to like what we've done in the past. Okay. So Susan, grading, correct?
Mm-hmm.
Can we do all of, we would do print, and then we would print,
Do you need to put print in front of it?
do we?
Not necessarily.
Okay.
Because
And
the function's calling print, right?
Functions.
Yeah.
I can't, I'm sorry, everybody's coming in at the same time. And then Susan dot switch.
Nice.
I like it.
Do we need to do Jeff too?
Maybe we could have added centimeters after
Oh, true.
shelf height. Just to make sure.
Yeah. And then, yeah.
And then I guess another way of changing switch on, we could have done just switch, and like if his electric was true, we would switch to false, and if his electric was false, he would switch it to true.
Well, that can be in the future work section of this robot. Okay, cool. And I trust that Jeff works. Thanks, you guys. Good job.
All right. So we'll go ahead and move on to the second part of the notebook here. I'll share my screen. Let's see. Can everyone see?
Mhm.
Okay. So for this next part, we're going to kind of expand on what we just learned and kind of learn two new things, initialization and inheritance. So if you recall up above, when we make a new robot, we have to create the instance of the robot, then we have to set their name and set their other attributes. But with classes, you can actually make them like functions where you can pass directly in the attribute values. So for example, we can make a robot class again and add a method. And so the method is called init, stands for initialization. It basically tells Python that whenever you create an instance of this class, always start by running the init method immediately. And the way you have to declare it is with 2 underscores init and then 2 more underscores. And you have to pass in self. And then what were our attributes? We want, let's see, name, material is electric, and number of arms. Name, material is electric, num of arms. All right. And now to set all of those variables, we have to do self.name equals the name that we passed in. Self.material equals material that we passed in. And self.is electric equals is electric. And then self.num of arms equals num of arms.
You're missing a couple of C's in your electrics there.
Am I?
In front of it.
Oh, I meant to do that, electric. All right. So once we have that, let's see, did we have other functions in here? We had electric shock and speak, so we'll go ahead and add those to it. All right, so now that we have our init method set up, we can make a new robot called Sally and do it all in one line. So we can do Sally equals robot. And then we want to keep the same order of the variables that we put in up here. So the name's Sally, the materials metal, is electric is true, and 3 arms. And then we can print out Sally's attributes. So Sally.name, Sally.material, Sally.is electric, and Sally.num of arms. And there we go. So it makes it a lot easier. You don't have to set up default values. And anytime you create an instance of the class, you can just do it all in one line and pass directly in the values you want. And it operates just like a normal function in Python. So like you could set a default value if you wanted to. So you could have it default to metal. And then if you end up not passing something in, it'll be a metal robot. And if you want to make it a different material, you can. Something else to keep in mind. All right, so now suppose we want to create a robot and have it battle other creatures. So we could create this class here. It's basically the same as above, except we added 3 new battle functions: attack, defend, and take damage. And so if we create a robot named Bob and fill in the attributes, notice we also added health in, because as it takes damage, its health goes down. And then if we just run all of the different battle commands, we can see it attacks, it takes damage, it defends itself. And if it takes enough damage, it dies. So now we want to create another creature, an alien, to fight the robot. So we kind of copied the same structure as the robot class, except aliens have an attribute called intelligence, and their greeting is a little bit different, but they also have the same attack, defend, and take damage methods. And then we can create our alien here, Glock, and just print out his different battle functions. So this kind of created a lot of duplicate code. Both the robot and the alien class have a name, they have health, and they have these 3 functions: attack, defend, and take damage. So this is where class inheritance comes in. We can make what's known as a superclass called creature, and then have our robot and alien classes inherit from that creature class. So the creature class can have those attributes that should be shared by the subclasses of robots and aliens. And then the robot and alien classes can have their own specific attributes and methods as well. So we can do class creature here. And we want to do our init method again. Pass in self. And then the 2 attributes are health and name that all creatures will have. Self.health equals health, and self.name equals name. And then we also want those 3 battle features, so I'm just going to copy and paste those from above. And let's see, I'm missing a semicolon. All right, so now we're going to create our robot and alien classes again, but this time we're going to inherit from the parent creature class. So we can do class robot, and now in the parentheses here, we pass in creature, because that's the class it's going to inherit from. And then we also want to do an init function, pass in self. And so we already have health and name, so what else did our robot had? It had a material, is electric, and was there something else? Num of arms, okay. All right, and like above, we, let's see, we set those 3 attributes. But now, how do we get the name and health to be set that we're inheriting from the parent class? Well, this is where you have to use what's known as super. Super basically says, go to the super function that this class inherits from, and then we're going to run the init method of it and pass in, actually up here we want to have our health and name, and then we pass in our health and name there. And so that will instantiate our health and name, and then also our more robot class specific attributes as well. And then what else did the robot had? It had, let's see, speak and electric shock. So we'll add those 2. All right, so now we'll do something similar for the alien class. So again, inheriting from the creature superclass, creating the init method. And again, we call super, and then its init method, passing in health and name, and then setting the intelligence. Okay, and then the alien also had a specific speak method. All right, so now we should have both of those new classes here. Let's see. Missing a semicolon. Okay, so now we're going to create Bob and Glock again, and then try calling their attack methods. So I'll just grab the code from up here. So Bob equals our robot class, and Glock equals our alien class. And I think we changed the order a bit of the variables to pass in. So it looks like it's health first. The robot had 1,000 health. And then name material is electric, and then number of arms. And similar for alien, we need to pass in the health first, then name, then intelligence. And so that should create our two creatures. And now if we want Bob to attack, Bob attacks. And if we want Glock to attack, Glock attacks. So you'll notice we didn't reference those attack commands at all. By passing in creature as the parent class, it just knows to go and find the methods available to that. You can think of inheritance like rushing nesting dolls. You can actually inherit multiple times. So you could have a parent class at the top, it could have a child class, that child class could have another child class, and it can go kind of on and on. So suppose we want to create a humanoid robot or android. This is going to be a class distinct from robot, but it's also still a robot, so it's going to inherit from robot. And then robot inherits from creature, so it will inherit from both robot and creature. So class android, and we're going to pass in robot, and then create the init method. And we want health and name is electric, num of arms, and also material. The robot has too many attributes, I think. And then the android should also have an attribute called singing skill, since it's humanoid. Let's see here. I keep misspelling electric, I know. Okay, and then we want to call super dot init. And so in this case, even though we're inheriting from the creature class all the way up, we're directly inheriting from the robot class. So we need to reference its init function and pass in those things here. So it needs the health, name, and material is electric, and number of arms. And then the only attribute it has for itself is the singing skill. So we'll just kind of set that here. Okay. And then it should have a function that allows it to sing. So we'll do sing here. And let's say if self.singing skill is greater than 50, somebody give me song lyrics. First thing you can think of. Anyone?
The happy birthday song.
Okay, happy birthday to you. Actually, we'll do that if they're a bad singer. And then if they're a good singer, what's a hard song to sing?
Ave Maria.
Ave Maria. I don't know the other words, but we'll just put it at that. All right. And then we can create an android. We'll do Andy the android. So we need to pass in health, the name, the material. We'll say it is still electric, has 2 arms like a human, and it has a singing skill of, let's see, we'll do 75. And then we can see if it can sing. And there it sings. So there you can see kind of the benefit of inheritance. Really the whole idea is to minimize redundant code as much as possible, make everything kind of compartmentalized, easy to follow, and that's kind of the whole nature of object-oriented programming. So now we're going to go into a really fun activity here. It's the battle to end all battles. You are going to create the most epic battle ever, Godzilla versus Mothra, as you can see in the picture here. So this is kind of what the battle should look like. They should enter the battle, yell their battle cry, then they should battle, and you should decide the winner, and they should print their victory cry. So we give you here the different parts that you need to have. There's different attributes you should include, and both Godzilla and Mothra should be part of a superclass called Megafauna. And so the Megafauna class should have all of these variables. And then you could create specific ones for the Godzilla and Mothra classes individually if you want. And then your goal is just to kind of have them battle here. Points to creativity. You can make this as fun as you want to. Let me see here. And yeah, I think that's it. How do you guys feel about doing that? Think you can handle it? Yes, no, thumbs up if yes. Iffy, maybe. Okay. Half thumbs up, half thumbs sideways.
Would you guys feel comfortable doing it in small groups like last time, or would you prefer to do it all together as a class? With one of you sharing the screen and transcribing the thought process.
I'd say it's
Either one, I don't care.
Other people are giving me kind of furrowed brows and okay. All right, Juliet votes together. Okay, cool. Oh, he's setting up a poll.
I was trying to.
Okay. I think by that time we could have been halfway through doing it.
Probably, but there it is. All right, it's looking like we're gonna do it together. So who wants to do the coding and share their screen?
Brendan wants to do it.
Yeah, we nominate Brendan.
Got it.
Voluntold.
So I'll stop sharing here. We'll go ahead and pause the recording, and then we'll reconvene when we're done.
All right, so for our battle, we defined our Megafauna class with animal type, height, weight, battle cry, victory cry, name, and opponents defeated. We passed in an empty list as the default value. Then we set all of them, instantiate all of them in the init function. We did yell battle cry, victory cry, and then for the battle, we used a random number generator where both contestants got 2 attacks that were a random number from 0 to 100 added together. And whoever won, that one was the winner, and we printed out the name is the winner and victory cry, and appended the opponent's name to the opponent's defeated. And then if obviously the opponent wins, it's the opposite print the opponent's name, the opponent's victory cry, and the opponent's defeated. And that's how we got our random number generator. So this is our Godzilla. It's a reptile. He's 1,000 meters tall. He weighs 5,000 pounds. His battle cry is just a lowercase roar. His victory cry is uppercase. Then obviously name. For Mothra, we did insect. Mothra is only 750 meters tall and only 2,500 pounds. Battle cry is bzz, and then capitalized version. And in our battle, Godzilla won. And then you can see here that Godzilla now has Mothra under its opponent's defeated list. You know what? Let's do it.
Best 2 out of 3.
Yeah. So we're going to do this live. This time, Mothra will have the battle. Whoops, forgot to tell it we need to do Godzilla. This time Mothra is the winner. Seems to be a little bit of a home field advantage here. And then finally, oh, Mothra comes back down one.
What happens if Mothra battles itself? Surprise, surprise.
That's great.
All right, so you guys remember the first 4 questions I asked at the beginning of the session. What is the template from which objects are instantiated called?
Class.
Yep. Someone who's not Brendan. Pass the hot potato. What is the name for a variable defined within a class to store a value?
Method.
I guess that one could be a method or an attribute. All right, someone who's not Jacob and also not Brendan. What is the instantiation of a class called? You guys are way overthinking this. It's in the title of the lesson.
Object-oriented programming.
Oh, well, just object.
Oh, object, sorry.
Yeah. All right. We got 2 left. You guys can duke it out for the final question. What type of class does not instantiate? This was in the learn.co material, but we did not cover it here.
Did the superclass or the highest level of whatever at what is it, adversity or something?
Abstraction.
Yeah, abstraction.
Yes, abstract classes do not instantiate. Okay. Yeah, we got a lot done in this study group, you guys. If you need to go, get your legs back under you, I understand a lot happened. But thanks, you guys. I really appreciate the hard work. That was a pretty amazing final activity. Yeah, it was hard to follow up that awesome SQL study group on Monday, but I think this one was a good successor. Marissa, spread the word back to your self-paced brethren that they can join us whenever they would like, and you are welcome here too. All right, y'all, work together on that class challenge. I've been seeing individual solutions trickle in, but this is not the point. Okay, thanks, you guys. Matt, do you have closing remarks?
Just good job, everyone. You know, as a data scientist, having a really good foundation in Python and object-oriented program is super important going forward. So definitely brush up on this until you're comfortable because you're going to use it constantly from this forward.
All right, Joe. Well, thanks. See you for one-on-ones or next week at study group.
Bye, everyone.